A type qualifier is an adjective you attach to a type, and C has three: const, volatile, and restrict. This lesson is about const, which you will use constantly, and the next covers the other two, which you will use rarely. Const means, I will not modify this through this name. Declare max as a const int holding 100, then try to assign to it, and the compiler stops you. Error, assignment of read-only variable max. Read that phrasing on the slide carefully, because the precise wording matters. Through this name, const is a promise about what you are allowed to do with a particular name, not a claim about where the value is stored or that it can never change. That distinction seems pedantic right up until you meet a const pointer to something that somebody else is modifying, which is a perfectly legal and occasionally useful thing to have. Where const gets confusing is on pointers, and there is one trick that makes it easy. Read the declaration right to left. Take the first one, right to left, that reads, P is a pointer to a char that is const. So the char cannot be changed through P, but P itself can be pointed somewhere else. The second, Q, is a const pointer to char. The pointer is fixed, but the character it points at is fair game. And the third, R, is a const pointer to a const char, so neither can be changed. The rule of thumb underneath the trick is that const applies to whatever is immediately to its left, unless there is nothing to its left, in which case it applies to what is on its right. That is why the first and second lines mean different things despite containing the same three words. Say them out loud, right to left, and you will get them right every time. So here is the practical instruction. Put const on every pointer parameter your function does not modify. Three things you get for it. First, it documents intent in the signature itself. Look at that copy function. One parameter is const and one is not, so you can tell which is the source and which is the destination without reading a word of documentation. That is a real convention, and the standard library follows it everywhere. Second, the compiler enforces the promise. If you later add a line that writes through S, the build fails, and it fails in the function that broke the rule rather than 3 layers away. And third, it widens what callers may pass. String literals live in read-only memory, so a function taking a plain char pointer cannot safely accept one. Take a const char pointer and it can. Const is free, it is checked, and it costs 5 characters.